Last thing for this unit is finding powers of I beyond I squared. So we have the identity of I to the first being I, or the square root of -1, which we use to identify I squared as being -1. So we have these two identities. Now let's consider that relationship between these exponents in order to find increasingly higher degrees. So I to the third can be thought of as I squared times I to the first. Well, we know that I squared equals -1, so I have -1 times I, which just equals -I. I to the fourth can be split as I squared times I squared. Well, I squared is -1, so if I have -1 times -1, that just equals a +1. We can follow this similar pattern by looking at these relationships. Now, my favorite exponent of I to use is I to the fourth because it just equals 1. It's the easiest one to do multiplication with. So I to the fifth, keeping that in mind, I can rewrite as I to the fourth times I to the first. I to the fourth just equals 1, so I have 1 times I, which is just I. And then I to the sixth I can rewrite as I to the fourth times I squared, which means I have 1 times -1, which equals -1. So continuing this pattern, we have I, -1, -I, and 1 for the first, second, third, and fourth degree. Then for the fifth power, we end up with I again because we have I to the fourth times I. I to the sixth is I to the fourth times I squared. That gives us the -1. I to the seventh gives us I to the fourth times I to the third, which is the same as I to the third. So we have -I. And then I to the eighth is I to the fourth times I to the fourth, giving us just a +1. Hopefully you see a pattern here, how we're cycling through these same four answers depending on what our exponent is. I to the ninth is I to the fourth, or more specifically, so I to the eighth, which we can think of as I to the fourth 2 times, and then multiplied by an extra I. Well, this whole thing just equals 1. Anytime my exponent is a multiple of 4, it's going to equal 1. So then I have I, and then following that same pattern, we end up with those same 4 solutions. One of the easiest things I've found to do is to figure out how much is left over after we break apart the greatest multiple of 4 as an exponent away from the exponent of the full power. Typically, what a lot of people will see is by doing long division to find what the remainder is. So one strategy that we can use is say, okay, is this exponent a multiple of 4? If it's not a multiple of 4, we need to figure out how much above a multiple of 4 it is. So if I take 15 and I divide it by 4, I know that 4 goes into 15 3 times, which is 12, and gives me a remainder of 3. So right here, I can consider that I to the fourth 3 times, that's I to the 12th. And then I have 3 left over, I to the third power. Well, again, any multiple of 4 is just going to equal 1. So this whole thing is going to equal 1. I just need to now focus on this I to the third power. So I've got 1 times I to the third. Now we think again how we broke this apart. I to the third was I squared times I, which is -1 times I, which is just -I. So I to the 15th falls in that same pattern of equaling -I. I to the 20th is a multiple of 4. This is equivalent to I to the fourth 5 times by using the power rule. 4 times 5 is 20. That means that I have 1 raised to the 5th power, which is just equal to 1. If I take 46, I want to figure out, well, what's the closest multiple of 4 that is less than 46? If you can think about the multiples, 44 is really close to 46. So I have I to the 44th times I squared. If I add those together, I get the 46. I to the 44th is I to the fourth 11 times I squared, which is -1. So I just have 1 times -1, which equals -1. If you had a hard time figuring out 44, again, you could just use the trick with the division. I want to divide 46. I want to divide 46 by 4. Goes in once, we subtract 4, we get a 0, bring down the 6. Goes in one time, subtract 4, we get a remainder of 2. So I have I to the 4th 11 times, that's what this is, I to the 4th 11 times, with I squared left over. This whole thing just equals 1, so I can ignore that. I don't need that. I'm just focused on the remainder part. I squared equals -1. Last but not least, we can just apply our properties of exponents. Even if it's an imaginary number, we still do the same thing where we can write it as 1 over I to the 13th power. Then we can split this into I to the 12th power times I. 12 is a multiple of 4. That means that this is going to be 1 times I. So I'm left with 1 over I. But again, we don't like i's in denominators, so we need to rationalize it. We can use our trick from before, where we can just multiply the top and the bottom by I since it's monomial, giving me I over I squared, which is I over -1, which just equals -1.